Welcome, and thank you for joining me in this quiet space. Here, we tell the gentle stories of science, weaving together the wonders of the universe into a soft tapestry to help you drift into a peaceful and restorative sleep. Tonight, our journey takes us upward, into the vast and silent theatre of the sky, to listen to the story of the clouds. We will explore these silent travellers, from the smallest whisper of their birth to their epic journeys across the continents, and finally, to their gentle return to the earth. Before we begin our ascent, I would love to know where you are listening from tonight, what patch of sky you are resting under. Please feel free to share in a comment below. And if you find a moment of peace here, please support this channel with a like and subscribe. Thank you so much. Now, settle in, close your eyes, and let your mind begin to drift. They are perhaps the most constant, and yet the most ever-changing feature of our world, a silent, shifting script written across the canvas of the sky. We see them as islands of white in an ocean of blue, as soft grey blankets on a winter morning, or as canvases for the fiery paintings of sunset. They are the great silent travellers, the carriers of rain and the makers of shade, and their story is the story of water, of air, and of light itself. To understand a cloud is to understand a fundamental breath of the planet, a slow and rhythmic exhalation that has shaped the world for eons. Their existence seems so effortless, so ethereal, that it feels almost magical, a spontaneous creation of the upper air. Yet their birth is a quiet and beautiful process, a convergence of the invisible and the visible, governed by the gentlest laws of physics. Every cloud you have ever seen, from the smallest wisp to the most towering thunderhead, is simply a visible community of countless, impossibly tiny liquid water droplets or frozen ice crystals, all suspended together, floating in the atmosphere. They are so small and so light that the gentle upward currents of air are enough to keep them aloft, allowing them to drift and wander on their journey. They are not solid, fluffy objects as they might appear from below, but rather a form of celestial mist, a gathering of moisture so vast that it becomes an entity in its own right. And the story of how this mist comes to be begins not with water itself, but with the air that holds its potential. All around you, in the very air you are breathing now, is water in its gaseous form, an invisible ocean of water vapor. It is odorless, colorless, and it is a constant presence, a measure of the air's hidden humidity. On a warm, humid summer evening, you can feel it on your skin, a certain weight and softness in the air, a promise of moisture held in suspension. This invisible vapor is the raw material, the ghost of water that must be coaxed back into a visible form. For this transformation to occur, the air must be cooled, and it must be cooled to a very specific and crucial temperature, a threshold known as the dew point. This is the magical moment, the tipping point where the invisible becomes visible. And this grand atmospheric process is something you have witnessed, and indeed created, on a much more intimate scale. Think of a cold winter's day. You step outside, into the crisp, clear air, and you exhale a deep, warm breath. For a moment, a small white cloud appears before you, a perfect miniature of the giants that drift far above. What you are witnessing is the birth of a cloud in the palm of your hand. The air leaving your lungs is warm and, like the air over a tropical ocean, it is saturated with invisible water vapor from within your body. As this warm, moist air meets the cold winter atmosphere, it is instantly chilled. It cools down past its dew point, and in that instant, the water vapor can no longer remain a gas. It must transform, and so it undergoes a process called condensation, shifting its state from an invisible vapor into a visible mist made of billions of tiny liquid water droplets. You have created a fleeting, personal cloud. This is precisely what happens high in the atmosphere, on a scale that is almost impossible to comprehend. A parcel of warm, moist air begins to rise, and as it ascends, it cools, until it finally reaches that critical dew point temperature. And there, in the cold silence of the upper air, the invisible ocean of water vapor begins to condense, molecule by molecule, into the first visible droplets of a new cloud. With this transformation, a tiny, almost imperceptible pulse of warmth is released into the surrounding air, an energetic signature of the change of state. This warmth is known as latent heat, a secret energy that was stored within the water vapor, and its release is the quiet heartbeat that can fuel the growth of a cloud from a gentle wisp into a towering storm. But for now, just imagine that first moment, the quiet and graceful appearance of form from formlessness, as the sky takes its first visible breath. And so the sky breathes, a vast and silent respiration that fills the atmosphere with these drifting worlds of white and grey. But for the sky to exhale these visible breaths, it must first inhale. And that great inhalation begins not in the air, but on the surface of the earth below. The water vapour that forms the clouds, that personal mist you see on a cold day, has to come from somewhere, and its journey is an ancient and epic one, a constant pilgrimage from the ground to the sky and back again. The ultimate source of this atmospheric moisture, the great reservoir from which the sky drinks, is the Earth's vast, dark oceans. Imagine standing on a quiet shore, watching the gentle rhythm of the waves under the warmth of the sun. The sunlight, travelling millions of miles through the cold of space, delivers its energy to the surface of the water. This solar energy is a gentle but persistent invitation, agitating the water molecules, giving them the energy they need to break free from the liquid embrace of the ocean. One by one, molecule by molecule, they escape, rising from the surface in a process called evaporation. They leave the ocean behind, transforming from liquid water into the invisible gas of water vapour, ascending into the air as a luminous ghost of their former selves. It is a silent and continuous exodus, an offering from the sea to the sky, happening at every moment of every day across more than 2/3 of our planet's surface. This constant, invisible rising is the first great step in the global water cycle, a closed and perfect system of planetary circulation that has been turning for billions of years. The water in the cloud you see today may have been part of the Pacific Ocean. Just weeks ago, lifted by the sun, carried by the winds, and now floating thousands of feet above a quiet countryside. This cycle connects everything. The water is not only drawn from the oceans, but from every lake, every river, and every stream. Even the dampness of the soil itself offers up its moisture to the air. The entire planet is breathing with the sun. But this process is not limited to bodies of water. It is a collaborative effort that includes the entire living world. Consider a great, ancient forest. Each tree, with its roots deep in the earth, is a silent engine, drawing water up through its trunk and out to its leaves. Through tiny pores on the underside of each leaf, the tree releases water vapor into the atmosphere in a process called transpiration. It is, in essence, the breath of the forest. A single large oak tree can transpire 40,000 gallons of water in a year, releasing it into the air as an invisible offering. When you see a forest cloaked in low-lying mist, you are witnessing the collective exhalation of all that life, a green and living fountain that is helping to seed the clouds above. So, the water vapor in the atmosphere is a traveller from many lands. It is the memory of the deep ocean, the spirit of a winding river, the cool dampness of the morning dew, and the living breath of the forest. It is a planetary composite, a mixture of waters from 1,000 different sources, all blended together in the great, invisible ocean of the air. When we look up at a cloud, we are not just seeing condensed water, we are seeing the culmination of this immense, silent journey. We are seeing the ocean that has learned to fly, the river that has ascended, the forest that has been lifted into the sky. Each cloud is a temporary gathering place for these ancient travellers, a fleeting congregation of water molecules that have been a part of this planet's story since its very beginning. They have been locked in glaciers, flowed in primordial rivers, and been part of every living thing that has ever existed. In this sense, the clouds are like a floating, ethereal archive of the Earth's history, a silent testament to the endless, beautiful cycle of renewal that sustains all life. And so this vapour, this ghost of the ocean and breath of the trees, now drifts in the lower atmosphere, waiting patiently for the next part of its story to unfold, carried on the wind, awaiting the silent uplift that will carry it high enough to be reborn. This invisible ocean of moisture, the ghost of the sea and the breath of the forest, now waits in the lower atmosphere, a vast potential held in the air around us. It has completed the first stage of its journey, ascending from the Earth's surface. But to be reborn as a visible cloud, it must continue its climb, journeying higher into the colder realms of the sky. This ascent is not an accident. It is guided by a set of silent and immensely powerful forces, the invisible architecture of the atmosphere that lifts and shapes the air. The most fundamental of these processes begins with a simple truth. As air rises, it cools. High in the atmosphere, the weight of the air above is less, and so the pressure is lower. A parcel of air rising into this low-pressure environment is able to expand, to stretch out. This act of expansion uses energy, and that energy is drawn from the heat within the air itself, causing its temperature to drop steadily with every 1,000 feet it climbs. This process, known as adiabatic cooling, is the foundational secret to cloud formation, the gentle chilling that brings the water vapor ever closer to its magical dew point, the moment of its transformation. One of the most common and beautiful engines of this uplift is powered directly by the sun. Imagine a summer field on a clear, calm day. The sun's rays warm the dark soil of the field, which in turn warms the pocket of air sitting directly above it. This patch of air becomes warmer, and therefore less dense, than the cooler, heavier air surrounding it. Like a log in water, or a hot air balloon, it has a natural buoyancy, an irrepressible urge to rise. And so it does. It breaks free from the ground and begins to ascend in a great, invisible column of rising warmth known as a thermal. These thermals are the silent elevators of the atmosphere, ridden effortlessly by hawks and glider pilots who have learned to read their invisible signs. As this bubble of warm, moist air rises, it expands and cools, and if it contains enough moisture and climbs high enough to reach its dew point, its invisible water vapor will condense into the puffy, cotton-like form of a cumulus cloud, a perfect, visible monument marking the very top of that rising column of air. This process, the transfer of heat through the movement of the air itself, is called convection, and it is the artist behind the scattered fair-weather clouds of a beautiful summer afternoon. But the sun is not the only force that can compel the air to rise. The very shape of the earth itself can be the catalyst. Picture a steady, moisture-laden wind blowing from the ocean, making its way inland until it encounters the magnificent, unmoving barrier of a mountain range. The air, having nowhere else to go, is forced to climb, flowing up and over the slopes and peaks. This is known as orographic lift, and as the air is forced higher, it cools, and its water vapor condenses into clouds that can shroud the mountaintops in mist and deliver life-giving rain to the windward slopes. Then, having crested the mountains and released much of its moisture, the air descends on the other side, warming as it is compressed, the clouds evaporating back into invisibility, leaving the land in a dry rain shadow. There is yet another, grander form of uplift, born from the slow and majestic meeting of vast bodies of air. The atmosphere is a mosaic of enormous air masses, some warm and humid, others cold and dry, each spanning thousands of miles. When two of these different air masses meet, they do not easily mix. The colder air is denser, heavier, and it clings to the ground like a great, invisible wedge. As the warmer, lighter air mass advances, it cannot push the cold air out of the way. Instead, it gently slides up and over it. This process, called frontal wedging, creates a slow, stable, and very widespread lift, often forcing an enormous sheet of warm air to rise over thousands of square miles. This is the force that so often creates the vast, uniform layers of stratus clouds, the grey, featureless blankets that can fill the sky from horizon to horizon, bringing with them a gentle, steady, and persistent rain. And so, through these silent, invisible hands, the focused warmth of the sun, the unyielding stone of a mountain, or the slow collision of air itself, the water vapor is guided on its upward path. It is lifted, stretched, and cooled, brought ever closer to the threshold of its becoming, the moment when it will finally transform from an invisible presence into a visible wonder. The journey is now almost complete. The moist air has been lifted by the silent hands of the atmosphere and has cooled to that crucial temperature, its dew point, where the invisible water vapor is finally ready to condense into tangible liquid form. It feels as though the stage is perfectly set, that in this cold, saturated air, a cloud should now spontaneously bloom into existence. And yet, here we find one of the most delicate and profound secrets of the sky. In air that is perfectly, chemically pure, a cloud would almost never form. The water vapor, even when it is cold and ready, needs one more thing. It needs a seed. It needs a surface, a microscopic anchor upon which to begin its transformation from gas to liquid. In the vast and seemingly empty expanse of the sky, these anchors are everywhere, a fine, invisible dust of tiny particles known as cloud condensation nuclei. The air, even on the clearest of days, is filled with these infinitesimal specks of solid matter, and without them, the sky would be a very different place. For water vapor to condense, the molecules need a place to gather, a physical platform to cling to and congregate upon. These nuclei provide that platform, serving as the microscopic heart around which every single cloud droplet is born. The origin of these tiny seeds is as varied and as beautiful as the clouds they help to create. They are, in essence, tiny pieces of the earth, lifted into the sky. Imagine the spray from a breaking ocean wave, flinging microscopic crystals of sea salt into the air, which are then carried high into the atmosphere by the wind. Imagine a great dust storm over the Sahara, lifting billions of tons of fine mineral dust and sand so high that it can travel across the entire Atlantic Ocean, eventually seeding the clouds that rain down upon the Amazon rainforest. Think of the smoke from a distant forest fire, or the ash from a volcanic eruption, each particle of soot becoming a potential seed for a droplet of water. Even the living world contributes, offering up microscopic grains of pollen from flowers or spores from fungi, all cast into the wind to become part of this atmospheric dust. And so the air is filled with this terrestrial grit, this blend of salt, dust, soot, and life. And it is upon this humble foundation that the magnificent architecture of the clouds is built. At the microscopic level, the process is one of elegant simplicity. A single water molecule, chilled and slowed by its ascent, encounters one of these nuclei. It clings to the surface. Soon, another water molecule arrives and joins it, and then another, and another, in a process called nucleation. An intricate, orderly gathering commences, as billions of these events happen in perfect synchrony throughout the rising parcel of air. A community of droplets begins to form, each one centered on its tiny, solid seed. And as this community grows and becomes more dense, it begins to scatter light, and finally, a cloud becomes visible to the human eye. Without these nuclei, the water vapor would be lost. It would need to achieve a state of extreme supersaturation, a humidity of well over 100%, for the molecules to begin spontaneously binding to each other, a condition that is almost never found in our natural atmosphere. The nuclei make the process easy, efficient, and possible. And in this fact, there is a deep and resonant poetry. The sky needs the earth to make its clouds. The vast, ethereal, and seemingly pure forms that drift above us are fundamentally tied to the dusty, gritty, and salty reality of the world below. The rain that falls to nourish the continents is born from the very dust of those continents. It is a perfect and beautiful cycle, a connection that binds the infinitesimal to the immense, the ground to the sky. And so the cloud is finally born, a visible testament to this collaboration, a floating commonwealth of countless droplets, each one holding a tiny speck of the earth at its core, now ready to take on a form, a character, and a destiny of its own. This newly born entity, this floating commonwealth of water and dust, now exists as a visible presence in the sky, ready to take on a character of its own. The shape a cloud assumes is not a matter of chance, but rather a perfect and living portrait of the air in which it resides. Its form is a direct expression of the atmosphere's movement, and its mood, revealing the invisible currents and the hidden stability of the sky. While the variety of clouds that grace our world may seem beautifully, bewilderingly infinite, the vast majority of these shapes can be understood as variations on three foundational forms, three great families of clouds that serve as the primary letters in the sky's visual alphabet. By learning to recognize these essential shapes, we can begin to read the story that the atmosphere is telling us every single day. The first and perhaps most familiar of these forms is the cumulus. The name comes from the Latin word for a heap or a pile, and it perfectly describes these cheerful, detached clouds. They are the classic clouds of a child's drawing. Puffy, brilliant white domes, like heaps of cotton, rising into the blue sky, all resting on curiously flat, grey bases. Their very shape is a story of their creation. They are born from the convection we spoke of earlier, the rising thermals of warm air. The flat, uniform base of a cumulus cloud marks the precise altitude where the rising air cooled to its dew point and condensation began. A perfectly level floor known as the condensation level. The puffy, rising towers above are the visible expression of that column of buoyant air, continuing its upward journey. When you see scattered cumulus clouds drifting through a summer sky, you are seeing a portrait of a stable atmosphere, of gentle uplift and calm conditions, each cloud a cheerful monument to a rising breath of warm air. The second foundational shape is the stratus. This name is derived from a Latin verb meaning to stretch or to spread out into a layer. Where cumulus clouds speak of vertical movement, stratus clouds tell a story of horizontal stability. They are not piled heaps, but rather vast, grey, featureless sheets that can stretch for hundreds of miles, often covering the entire sky like a soft, diffuse ceiling. They are born not from focused thermals, but from the gentle, large-scale lifting of an entire layer of stable air, often when a warm air mass slowly glides over a cooler one. There are no strong vertical currents to build them into towers, so they spread out, creating the calm, quiet uniformity of an overcast day. These are the clouds of contemplation, the clouds that bring a soft, even light to the world below. A stratus cloud can sometimes form so low that it touches the ground, and when this happens, we give it a different name. We call it fog or mist. To walk through fog is to walk within a cloud, to be surrounded by the same substance that floats thousands of feet above. And finally, the third of these primary forms is the cirrus, whose name comes from the Latin word for a curl of hair. These are the most delicate and ethereal of all clouds, found in the highest, coldest regions of the troposphere, 6 miles or more above the Earth. They are too high, and the air is too cold for them to be made of liquid water droplets. Instead, they are composed entirely of tiny, falling ice crystals. They appear as thin, white, wispy filaments, silky and feathery, often stretched across the sky by the fierce, high-altitude winds of the jet stream. These winds shear the falling ice crystals into long, delicate streaks, sometimes called mare's tails. Cirrus clouds do not block the sun, but rather create a soft, luminous veil. They are the graceful messengers of the upper atmosphere, and their presence often signals a change in the weather, a silent, beautiful warning that a weather front is approaching. And so, we have the 3 primary words of the sky's language: the heap, the layer, and the curl. Cumulus, stratus, and cirrus. Each one a beautiful form in its own right, and each one a key to understanding the great, silent movements of the air. With these 3 foundational shapes, the heap, the layer, and the curl of hair, we are given the basic letters of the sky's alphabet. For centuries, humanity looked up at these forms, giving them poetic and folkloric names, seeing in them the fleeting shapes of animals and gods. But there was no common language, no scientific framework to connect the clouds seen in England with those seen in Italy or France. The sky was a beautiful but ultimately chaotic and unordered text. This all changed at the very beginning of the 19th century, thanks to the patient and brilliant mind of a man who was not a professional scientist, but a humble London pharmacist and amateur meteorologist with a lifelong passion for the sky. His name was Luke Howard, and it was he who first gave the clouds the elegant, universal language that we still use to this day. In the year 1802, in a lecture to a small scientific society, Howard presented a wonderfully simple and powerful system for classifying these silent travelers. He understood that a truly useful system needed to do more than just describe a few shapes. It needed to be flexible enough to account for the sky's infinite variety. And for his language, he turned to Latin, which was then the universal language of science, ensuring his system could be understood by naturalists all across the world. He began with the three primary forms we have just explored, giving them their classic Latin names: cirrus, the curl; cumulus, the heap; and stratus, the layer. But the true genius of his system was in how he combined these foundational names to describe the clouds that were transitions or combinations of these pure forms. He recognized that the sky was not static, and his language needed to reflect that fluidity. His great insight was to add prefixes and suffixes that described a cloud's altitude and its character. He observed that clouds often appeared in distinct layers in the sky, and so he introduced the prefixes that designated height. For the high clouds, he used cirro. So, a high-altitude cloud that was flat and layered, like a thin, white sheet, he called cirrostratus. For the mid-level clouds, he introduced the prefix alto, and so a mid-level sky filled with puffy, heaped clouds became known as altocumulus. This simple addition of altitude allowed observers to describe the sky with a newfound precision, creating a much richer and more descriptive vocabulary. Finally, he added one more crucial element, a word to describe a cloud's most important function: its ability to produce rain. For this, he used the Latin word nimbus, meaning rain cloud. He used it as a prefix, nimbo, or a suffix, nimbus. And with this, the system was complete. A dark, grey, layered stratus cloud that was producing a steady rain became nimbostratus. And a great, towering cumulus cloud that had grown large enough to create a thunderstorm with its characteristic downpour became the king of clouds, the mighty cumulonimbus. In this single act of naming, Luke Howard transformed our relationship with the sky. His work gave meteorologists a shared, scientific language, allowing them to communicate their observations with clarity for the very first time. It was an act of profound poetry, finding a deep and elegant order in the most ephemeral and changeable of nature's creations. It did not take away from the mystery of the clouds, but rather added a new layer of understanding and appreciation. Thanks to the quiet observations of a London pharmacist, we were no longer just passive admirers of a beautiful, chaotic sky. We were now able to read its intentions and to understand the grand story it was telling. The sky was now organized, its forms named and its character understood, allowing us to see the deeper narratives constantly unfolding above us, like the epic journey of a single gentle cloud as it grows into a great and powerful storm. With the elegant language Luke Howard gave us, the sky becomes a readable text, its beautiful forms no longer a mystery, but a story unfolding in a language we can understand. We can now move beyond simply naming the clouds and begin to follow their biographies, to witness the dramatic life cycle of a single cloud as it transforms from a gentle wanderer into a being of spectacular and formidable power. Our story begins, once again, with a humble cumulus cloud, a cheerful puff of white, born from a warm thermal on a summer's day. On most days, the atmosphere is stable, meaning that as a parcel of air rises, it cools quickly, and soon becomes the same temperature as, or even colder than, the air surrounding it. Its buoyancy is lost, and its ascent comes to a gentle halt. But sometimes, the conditions are different. The atmosphere can become unstable. This happens when the air cools with height much more rapidly than usual, creating a situation where a rising parcel of warm air remains significantly warmer and less dense than its environment, even as it cools. Its upward journey is no longer gentle. It becomes a powerful, self-sustaining acceleration, like a cork held deep underwater and then suddenly released. In this unstable air, a humble cumulus cloud, known as cumulus humilis, does not stop growing. Fed by this powerful, accelerating updraft, it begins to climb with purpose, its towers billowing upward, growing into a much larger and more congested form known as cumulus congestus. This is a cloud with ambition, a towering heap that is already a sign of the immense energy being unleashed in the atmosphere. And as it continues its relentless climb into the colder upper reaches of the sky, it undergoes its final, magnificent transformation, becoming the undisputed king of all clouds, the mighty cumulonimbus. The secret to this explosive growth, the engine that drives a small cloud into a towering thunderhead, is a force we have already met: the latent heat of condensation. As the powerful updraft lifts vast quantities of warm, moist air, that water vapor condenses into cloud droplets. This process, on a truly massive scale, releases a tremendous amount of heat energy directly into the core of the rising cloud. This constant release of warmth makes the air inside the cloud even more buoyant, strengthening the updraft, which in turn pulls up even more moist air from below, which then condenses and releases yet more latent heat. It is a powerful and extraordinary feedback loop, a chain reaction where the cloud is literally feeding itself, its growth fueling ever more growth. The energy unleashed in this process is difficult to comprehend. A single, mature thunderstorm can release as much energy as a small atomic bomb, all of it derived from the simple phase change of water from gas to liquid. This vertical ascent, however, cannot continue forever. The cloud's climb is eventually halted by a natural boundary high in the atmosphere, known as the tropopause. This is a layer where the temperature of the air stops decreasing with height and actually begins to increase. It is a strong inversion that acts as an impenetrable ceiling. When the powerful, rapidly rising updraft of the cumulonimbus cloud hits this ceiling, it can no longer go up, and so it is forced to spread out horizontally. The top of the cloud flattens and expands, carried by the high-altitude winds, into the iconic, majestic shape of a blacksmith's anvil. This anvil is the storm's great crown, a clear sign that the cloud has reached its full maturity and power. Its edges are often soft and fibrous, as they are composed entirely of ice crystals, sheared and stretched by the winds of the jet stream. To see a cumulonimbus cloud with its great anvil top is to witness one of the most powerful and beautiful events in nature. A true cathedral of the sky, a place of profound transformation, where the gentle energy of the sun and the moisture of the ocean are converted into the spectacular and elemental forces of the storm. To stand and watch that great cathedral of the sky, the mighty cumulonimbus, is to feel a sense of profound awe at its power. But its beauty is not just in its scale and energy, but also in its simple visual presence, in the way it interacts with the light of the sun. And this raises a gentle question. How can something made from simple, transparent water droplets create the brilliant whites, the deep greys, and the fiery oranges that paint the sky? The story of a cloud's color is the story of light itself on its journey through the atmosphere. The reason that most clouds appear a brilliant, luminous white begins with the size of the water droplets they contain. While these droplets are microscopic, they are still significantly larger than the wavelengths of visible light. Because of their size, they act as wonderful, impartial scatterers of sunlight. When a ray of sunshine enters a cloud, its light is bounced and reflected from one droplet to another, again and again, in a random, chaotic dance. During this dance, all the colors of the spectrum, the reds, greens, and blues, are scattered more or less equally in all directions. When this combination of all the colors of light emerges from the cloud and travels to our eyes, our brains perceive this full spectrum mixture as the color white. This process is known as Mie scattering. It's the same reason that salt or sugar, which are made of clear crystals, appear white, because the light is scattered randomly by their many facets. A cloud is simply a vast, floating sculpture of white light. If this is so, then why do clouds, especially the great storm clouds, so often appear dark and grey? The answer is not a change in their composition, but simply a matter of thickness and of shadow. As a cloud grows taller and more dense with water, it becomes more opaque. More and more sunlight is scattered and reflected away from the cloud's top surface, and less light is able to penetrate all the way through its deep and turbulent interior. The base of a very tall and dense cloud is therefore in its own shadow. The darkness we see is simply the absence of direct light, the same way a thick, heavy curtain will darken a room on a sunny day. A dark cloud is not an angry cloud. It is simply a very deep cloud. The most spectacular colors, however, are reserved for the beginning and the end of the day. To understand the magic of a sunset, we must first understand why the sky itself is blue. The molecules of nitrogen and oxygen that make up our atmosphere are very, very small, far smaller than the wavelengths of light. These tiny molecules are much better at scattering the shorter, higher energy wavelengths of light, which are the blues and the violets. This is a different process, known as Rayleigh scattering. As sunlight streams through the atmosphere, this blue light is scattered in every direction, so that from our perspective on the ground, the entire sky appears to be filled with a soft, blue glow. But at sunrise or sunset, the sun is very low on the horizon, and its light must travel through a much longer, thicker path of atmosphere to reach us. On this extended journey, most of the blues and greens are scattered away from our direct line of sight by the air molecules. Only the longer, more resilient wavelengths, the beautiful oranges, pinks, and reds, are able to make it all the way through. The clouds, floating high in the sky, now become the perfect canvas for this filtered, coloured light. They are no longer illuminated by white sunlight from above, but by this reddened light from the side. They catch these last, warm rays of the fading day and reflect them down to us, transforming from simple white clouds into magnificent, glowing sculptures of fire and rose. They are not creating the colour themselves. They are simply revealing the hidden, beautiful story of the sunlight's long and gentle journey to the edge of night. This great cloud, now painted in the soft, fading colours of the sunset, is a thing of immense visual beauty, a silent, floating sculpture against the deepening blue of the sky. But within its magnificent form, a hidden energy is gathering, a quiet and growing tension that will soon be released in one of nature's most spectacular displays. For the cumulonimbus cloud is not just a passive carrier of water, it is a vast and powerful electrical generator, and as it matures, its turbulent heart begins to beat with an electric pulse. Inside the immense vertical currents of the storm, a chaotic and constant dance is taking place. The powerful updrafts carry millions of tiny, lightweight ice crystals high into the cloud, while heavier, soft pellets of hail, known as grapple, are falling and cycling through the storm's core. As these rising ice crystals and falling grapple particles collide in the churning interior, a subtle but crucial exchange occurs. Electrons, the tiny particles that carry a negative charge, are stripped away from the ice crystals and collected by the grapple. This simple act of friction, repeated countless trillions of times, begins to sort the cloud's electrical charge. The lighter ice crystals, which have now lost electrons and are left with a positive charge, continue their journey to the very top of the cloud. The heavier grapple particles, which have collected these electrons and now carry a negative charge, tend to accumulate in the lower and middle regions of the cloud. Through this majestic and turbulent process, the cloud becomes a vast atmospheric battery with an enormous positive charge at its crown and an equally enormous negative charge at its base. As this separation of charge intensifies, a powerful electric field builds between the cloud and the positively charged ground below, a silent, growing tension that the air itself cannot contain for long. The release, when it comes, is a sequence of breathtaking speed and power. The immense pool of negative charge at the cloud's base begins to seek a path to the ground, sending down a branching, exploratory feeler of electrons called a stepped leader. It travels in short, sharp bursts, seeking the path of least resistance through the air. As it draws near to the surface, the powerful negative field induces a positive charge on the ground below, and this charge gathers on the tallest objects, a lone tree, a church steeple, a blade of grass. An upward-reaching streamer of positive charge then rises to meet the descending leader. The moment they connect, the circuit is complete. An invisible channel is formed, and in a brilliant, blinding flash, the massive electrical discharge of the return stroke surges up this channel from the ground to the cloud, neutralizing the charge. This is the part we see as a lightning bolt. In that fraction of a second, the air inside this channel is heated to a temperature of nearly 30,000 degrees Celsius, a temperature hotter than the surface of the sun. This extreme and instantaneous heating causes the surrounding air to expand outwards explosively, creating a powerful sonic shockwave that radiates away from the lightning channel. This shockwave is the deep and resonant sound that we call thunder. It is the sky's great exhalation. the sound of the atmosphere reeling from that sudden, brilliant release of energy. And the reason for the familiar delay between the flash and the sound is the vast difference in their travel speeds. Light moves at the ultimate speed limit of the universe, close to 300 million meters per second, so the flash of lightning reaches our eyes almost instantly. Sound, however, travels through the air much more slowly, at a gentle pace of around 343 meters per second. This delay is a perfect, natural measure of the storm's distance, a slow, rumbling reminder of the true and immense scale of the atmospheric engine that is at work, balancing its energy in a beautiful and powerful rhythm of light and sound. The great cumulonimbus, with its electric heartbeat and powerful voice, is the most dramatic and commanding presence in the sky's pantheon. It is the cloud of high drama and immense force, a common and magnificent spectacle of the atmosphere's power. But beyond these grand and often tumultuous displays, the atmosphere has a quieter, more subtle, and perhaps more artistic side. It is a master sculptor, capable of creating formations of such strange and fleeting beauty that they seem to belong to another world. These are the rare and wondrous wanderers of the sky, the clouds that reward the patient and fortunate observer with a glimpse of the atmosphere's hidden poetry. On rare occasions, over mountain ranges, one might see a series of smooth, white, lens-shaped clouds hanging in the sky, looking remarkably like a stack of plates or a fleet of silent, otherworldly ships. These are lenticular clouds, and their serene, sculpted appearance belies the powerful winds that create them. They form when a swift, stable, and moist layer of air is forced to flow up and over a mountain. As the air rises, it cools, and the moisture condenses, forming a cloud. As the air then flows down the other side of the peak, it warms up, and the cloud evaporates back into invisibility. The remarkable thing is that the cloud itself remains almost perfectly stationary, suspended in place, even as the wind streams continuously through it, much like a standing wave that forms behind a rock in a fast-moving river. They are a perfect, visible expression of the invisible currents of the air, a silent and graceful monument to the wind. Far, far above these, at the very edge of space, in the cold, thin air of the mesosphere, are the highest clouds in our atmosphere, the beautiful and mysterious noctilucent clouds. Their name means night shining, and they are so high up, over 50 miles above the surface, that they can remain illuminated by the sun long after it has set for those of us on the ground. They are visible only in the deep twilight of summer, from latitudes near the poles, appearing as incredibly fine, electric blue or silver wisps, often with intricate, rippling patterns. They are thought to be made of microscopic ice crystals that have formed around the fine dust left behind by meteors burning up in the atmosphere. To see them is a breathtaking and unforgettable experience, a quiet, shimmering link between our world and the vast, dark cosmos beyond. Sometimes, in the unsettled air following a powerful thunderstorm, you might look up at the underside of the great anvil cloud and see a strange and beautiful pattern of soft, pouch-like lobes hanging down. These are mammatus clouds, named for their resemblance to udders. They are one of the few clouds formed by sinking, rather than rising, air. As pockets of cold, moist air from the top of the storm sink into the drier air below, they warm more slowly than their surroundings, and the water droplets within them persist for a time, creating these wonderful, pendant-like shapes. They are often illuminated by the low sun after a storm has passed, creating a truly spectacular, almost surreal, golden, bubbling ceiling. They are a sign of the storm's gentle decay, a calm and beautiful aftermath. And perhaps most fleeting of all are the Kelvin-Helmholtz clouds, which appear for only a few minutes at a time as a perfect, repeating series of breaking ocean waves in the sky. They are the result of a strong wind shear, when a fast-moving layer of air flows over a slower layer below, creating a beautiful, rolling instability. They are a rare and stunning visualization of the fact that the air we move through every day is a vast, invisible fluid, with currents and waves and eddies, just like the great oceans. These quiet masterpieces remind us that the sky's creativity is boundless, and that for those who take the time to look up, there is always another layer of subtle and profound beauty waiting to be discovered. These rare and beautiful masterpieces of the sky, the lenticular lenses and the noctilucent wisps, remind us that the atmosphere is a place of endless creativity. But as unique and localized as these formations may seem, they are each a small part of a much grander, interconnected system that operates on a planetary scale. To truly understand the story of the clouds, we must now zoom out, pulling our perspective away from the individual cloud until the continents themselves come into view, and we can begin to see the great, silent, invisible currents that govern the entire sky. It is on this grand scale that we discover that the atmosphere has its own rivers. They are not made of liquid water, but of immense, concentrated streams of airborne water vapor, flowing for thousands of miles through the sky. These phenomena, known as atmospheric rivers, are long, narrow corridors of moisture, sometimes only a few hundred miles wide, that carry a volume of water vapor equivalent to, and often far greater than, the flow of the mightiest rivers on the ground, such as the Amazon. These invisible rivers in the sky are the great arteries of the planet's water cycle, drawing moisture from the warm, humid tropics and transporting it across vast oceans to the cooler, drier coastlines of the mid-latitudes, where they deliver the rain and snow that sustain entire ecosystems. The engine that drives these rivers, and all the great winds of the world, is the simple, powerful, and relentless energy of the sun. At the equator, the sun's rays are most direct and intense, warming the ocean and the air above it. This warm, humid air, being light and buoyant, rises high into the atmosphere, creating a permanent belt of low pressure. As this air reaches the upper atmosphere, it spreads out and begins to travel towards the poles. On its journey, it cools and radiates its heat into space, eventually becoming dense enough to sink back down to the surface in the subtropics, around 30 degrees latitude. This descending air then flows back along the surface towards the equator to replace the rising air, completing a vast, looping, atmospheric conveyor belt. This enormous, rotating cell of air, known as a Hadley cell, is the fundamental engine of our planet's climate. Similar, though weaker, cells exist at the mid-latitudes, the feral cells, and at the poles, the polar cells. Together, these great, turning wheels of air are the planet's system of deep breathing, a global respiration driven by the difference in temperature between the warm equator and the cold poles. The region where this great uplift begins, the band around the equator, where the trade winds from the northern and southern hemispheres meet, is known as the Intertropical Convergence Zone, or ITCZ. Here, the converging winds force the warm, moisture-laden air to rise, creating a spectacular, globe-circling belt of towering cumulonimbus clouds and thunderstorms. This is the vibrant, rainy engine room of the planet, the great seam of the atmosphere where the majority of the world's weather is born. And high above all of this, racing along the boundaries between these great circulation cells, are the jet streams. These are narrow, fast-flowing rivers of air, meandering across the globe at speeds that can exceed 200 miles per hour. They are the invisible highways of the upper atmosphere, formed by the sharp temperature contrasts between the great air masses, and they steer the weather systems below, guiding the paths of storms and directing the flow of the atmospheric rivers on their long journeys across the planet. And so the lone cloud drifting peacefully over a quiet landscape is never truly alone. It is a passenger on these immense and ancient currents, its journey dictated by the slow, deep breath of the Hadley cells and the swift, high currents of the jet stream. The water it carries may have evaporated from a distant ocean, and the rain it is about to release is the final destination of a pilgrimage that has spanned half the globe, a beautiful and humbling reminder that our world's atmosphere is a single, flowing, and deeply interconnected whole. To see the clouds as passengers on these great global currents, as carriers of water in the sky's invisible rivers, is to appreciate their vital role in nourishing the planet. But these silent travelers carry more than just the potential for rain. They are also profound and powerful regulators of the planet's energy, of its very temperature. They perform a delicate and crucial dance with the light of the sun, a dance that is defined by a deep and beautiful contradiction. For clouds have a dual nature. They can simultaneously cool the earth and warm it, acting at times as a brilliant, reflective shield, and at other times as a soft, insulating blanket. This constant, planetary-scale balancing act is one of the most important and complex functions in our entire climate system. First, let us consider the cloud as a shield. Imagine the Earth as seen from space, a blue marble swirled with the brilliant white of its cloud cover. The white tops of low, thick clouds, like the vast sheets of stratocumulus that form over the oceans, are incredibly reflective. This quality of reflectiveness is known as albedo. These clouds, with their high albedo, intercept a significant portion of the incoming radiation from the sun and reflect it directly back into space before it has a chance to reach the surface and warm the land and sea below. This is known as the albedo effect, and its influence is immense. It is estimated that if the Earth had no clouds, it would absorb roughly 20% more heat from the sun, and our planet would be a much, much hotter place. In this way, the low, bright clouds act as the planet's great parasol, a cooling shield that graciously protects the biosphere from the full intensity of the sun's fire. But clouds can also play the opposite role, that of a warm and insulating blanket. This is most true of the high, thin, wispy cirrus clouds that drift in the cold upper reaches of the atmosphere. Because they are thin and translucent, they allow most of the sun's incoming, shortwave energy to pass right through them to warm the Earth's surface. However, the Earth, now warmed, radiates its own energy back outwards in the form of long-wave, infrared radiation. What we feel as heat, these high, cold cirrus clouds, made of ice crystals, are very effective at absorbing this outgoing heat radiation and then re-radiating a portion of it back down towards the surface. This process traps warmth in the atmosphere that would otherwise have escaped into space. It is a form of the greenhouse effect, and it is why a clear night is often much colder than a night with a thin veil of high cloud cover, which acts as a gentle celestial blanket, tucking the world in for the night. So whether a cloud has a net cooling or a net warming effect depends on its nature, its altitude, its thickness, and the size of the droplets or ice crystals within it. As a general rule, low, thick clouds tend to be net coolers, as their powerful albedo effect dominates. High, thin clouds, on the other hand, tend to be net warmers, as their greenhouse effect is more significant. This delicate and complex duality, known as cloud feedback, makes clouds one of the most critical and challenging elements in our understanding of the Earth's climate. And so, when we gaze up at the sky, we are seeing more than just the weather. We are witnessing the workings of the planet's great thermostat, a beautiful and complex living system, constantly adjusting its shield and its blanket, forever mediating the delicate, life-sustaining balance between the deep, cold darkness of space and the brilliant, unwavering fire of our star. We have seen the clouds as a great physical engine, a planetary thermostat that shields and blankets the Earth, maintaining the delicate balance that makes this world a home for life. This perspective reveals a profound connection between the atmosphere and the biosphere, a partnership in regulating the climate. But the connection is deeper and more intimate than we could ever imagine. Clouds are not just a sterile physical process that creates an environment for life. They are, in themselves, a living environment, a vast, high-altitude ecosystem teeming with unseen biological activity. The air, even in the clearest blue sky, is not empty. It is filled with a constant, invisible rain of microscopic life, a community of organisms known as aeroplankton. These are the smallest and most resilient of life's travelers. Bacteria, archaea, algae, fungi, and viruses, all swept up from the surfaces of leaves, from the soil, from the spray of the ocean, and cast into the great currents of the atmosphere. They drift for days or weeks at a time, forming a sparse but sprawling ecosystem in the sky. For these tiny organisms, a cloud is an oasis. Within its misty confines, they find the essential ingredient for life that is so scarce elsewhere in the atmosphere: liquid water. Each cloud droplet becomes a temporary, microscopic world, a mobile home providing moisture and sometimes even dissolved nutrients. While it is certainly a harsh habitat, with its freezing temperatures and high levels of ultraviolet radiation, for these hardy microbes, it is a viable, if transient, home. And more than just a habitat, The clouds are a global transportation system for life itself. Caught within a weather system, these tiny organisms can be carried across entire continents and oceans, achieving a scale of dispersal that would be utterly impossible on their own. A bacterium from a leaf in the Amazon could find itself, weeks later, falling in the rain over Africa, a testament to the cloud's power to connect the world's most distant ecosystems. But perhaps the most wondrous part of this story is the idea that these tiny living passengers may not be passive travelers at all. There is a beautiful and growing body of evidence for a theory known as bioprecipitation, which suggests that some of these microbes may be active participants in the creation of rain and snow. Certain species of bacteria, most famously Pseudomonas syringae, which is commonly found on plants, are astonishingly effective at acting as nuclei for the formation of ice. They produce a special protein on their outer membrane that has a unique ability to arrange water molecules into a crystal lattice, tricking the water into freezing at much warmer temperatures, as high as -2 degrees Celsius than it would on its own, where it can remain supercooled to nearly -40 degrees. In essence, these bacteria are the world's most efficient natural ice formers. This raises a breathtaking possibility. By promoting the formation of ice crystals in a cloud, which is the primary mechanism for generating snow and rain in temperate climates, these bacteria may actively influence the weather. It may be an evolutionary strategy, a way for the bacteria to complete their atmospheric journey and return to the ground where they can thrive and reproduce. It suggests that life is not merely subject to the weather, but may, in a very real and tangible way, help to create it. The rain that nourishes a forest may be triggered, in part, by the very bacteria living on the leaves of that forest. A perfect and profound feedback loop. And so, the cloud is transformed in our understanding, from a simple collection of water droplets into a living, breathing entity in the deepest sense, a testament to life's incredible tenacity and its ability to shape the very planet that it inhabits. These living clouds, these high-altitude ecosystems, teeming with terrestrial microbes and participating in the great water cycle of our planet, are a wonder of biology. They are a uniquely earthly phenomenon, a direct result of a world covered in oceans of liquid water and abundant life. But as we let our imaginations drift further, beyond the pull of our own world, we might ask, is this the only way for a sky to have clouds? And so we begin a quiet journey through our solar system, to visit the skies of our planetary neighbours, and to witness the extraordinary variety of clouds the cosmos can create. Our first stop is Venus, the planet named for the goddess of love and beauty, a world permanently shrouded in a thick, unbroken veil of pale, yellow-white clouds. From a distance, it is serene and beautiful, but these are not the gentle water clouds of Earth. The clouds of Venus are composed of droplets of highly corrosive sulfuric acid. This dense, globe-spanning cloud layer is so thick that it reflects most of the sunlight back into space, making Venus brilliant in our night sky, yet it also traps the heat that does get through, creating a runaway greenhouse effect. Beneath this beautiful, acidic veil, the surface of Venus is a crushing, desolate landscape, with temperatures hot enough to melt lead. Its clouds are a beautiful but terrifying warning of how different a world so similar in size to our own can be. We move outwards, to Mars, the red planet. Its atmosphere today is thin and cold, a mere ghost of what it might once have been. Yet even here, in this thin, pink sky, clouds can still be found. They are delicate, wispy things, much like our highest cirrus clouds, drifting over the colossal peaks of its extinct volcanoes. These Martian clouds are primarily made of water ice, a fragile reminder of the water that still exists on Mars, locked away in its polar caps and beneath its surface. And in the frigid Martian winter, near the poles, a different kind of cloud can form, one made of frozen carbon dioxide or dry ice. These are the ghostly, ethereal clouds of a world in a deep and lasting ice age. Our journey continues out into the realm of the gas giants, to the immense and majestic Jupiter. Its atmosphere is a turbulent masterpiece of colourful bands and swirling storms, and its clouds are not a single layer, but a complex, multi-tiered system. The highest, whitest clouds we see are made of crystals of frozen ammonia. Beneath this top layer is a second deck of clouds, thought to be made of a compound called ammonium hydrosulfide, which may be responsible for the planet's famous red, brown, and orange hues. And deeper still, far below the visible tops, lies a third layer of clouds, one made of familiar water ice and liquid water droplets. Jupiter's great red spot is a colossal hurricane, a storm larger than our entire planet, raging for centuries within these deep chemical cloud decks. We travel further, to the cold, distant reaches of the solar system. We visit Titan, Saturn's largest moon, a world with a thick, hazy, orange atmosphere. Here it is so cold that water is a frozen, rock-hard mineral. Instead, the role of water is played by methane and ethane. On Titan, there are clouds of liquid methane, which drift through its nitrogen sky, producing a slow drizzle of methane rain that carves river channels and fills vast lakes and seas of liquid hydrocarbons on its surface. And finally, we glimpse the deep, sapphire blue world of Neptune, where the fastest winds in the solar system, screaming at over 1,000 miles per hour, whip clouds of frozen methane crystals across the planet's face. After this grand and silent tour of alien skies, we return to the soft, familiar blue of our own. Our cosmic perspective reveals just how precious and unique our own clouds truly are. They are not made of acid or ammonia or methane, but of gentle, life-giving water. They exist in a perfect thermal balance that allows that water to exist as a liquid, a solid, and a gas. And most wondrous of all, they carry life within them. The soft, white, silent travelers of our own sky are an extraordinary treasure, the hallmark of a world perfectly, beautifully, and perhaps uniquely tuned for life. Our journey to the far-flung skies of other worlds brings us home with a renewed sense of wonder for the gentle, living clouds of our own planet. We have followed their story from a single molecule of water leaving the ocean to the invisible forces that lift it, to the tiny speck of dust that gives it form. We have witnessed its growth into a great thunderhead and its role in the grand, planetary systems of wind and warmth. But the journey of a cloud and of the water it holds is a cycle, and it is not complete until it makes its final, graceful return to the earth. This is the story of a cloud's dissolution, a gentle and beautiful end that is also a vital new beginning for the world below. A cloud, in its stable state, is a delicate balance. Its countless water droplets or ice crystals are so impossibly tiny and light that even the gentlest of upward air currents are enough to keep them suspended, floating effortlessly in the sky. For precipitation to occur, for rain or snow to fall, these microscopic droplets must grow enormously, increasing their volume by around 1 million times, until they are heavy enough to overcome the air's lift and begin their descent. This transformation from a floating mist to a falling rain happens through two beautiful and elegant processes. In the warmer regions of the world, in clouds whose temperature is entirely above freezing, the process is one of patient, gentle growth. The cloud droplets are not all of the exact same size, and the slightly larger ones fall a little bit faster through the cloud than their smaller neighbours. As these larger collector droplets descend, they bump into and merge with the smaller droplets in their path. This is the collision and coalescence process. It is a slow, gradual accumulation, a quiet dance of countless droplets merging and becoming one, until finally, a droplet grows large enough and heavy enough to fall from the base of the cloud as a drop of rain. In the cooler climates that cover most of our planet, however, a more complex and fascinating process is at work, one that involves a magical collaboration between ice and water. These cold clouds are a mixture of tiny ice crystals and droplets of supercooled water. Water that has remained in its liquid state, even though the temperature is well below 0 degrees Celsius. In this mixed environment, a subtle competition for water vapor begins. For reasons of molecular physics, the water vapor molecules in the air are more strongly attracted to the crystalline surface of the ice than they are to the liquid surface of the water droplets. And so, the ice crystals begin to grow rapidly, pulling water vapor directly out of the air. This, in turn, causes the nearby supercooled water droplets to evaporate, replenishing the water vapor, which is then quickly deposited onto the growing ice crystals. This beautiful and efficient mechanism, known as the Bergeron process, allows the ice crystals to grow very large at the expense of the shrinking water droplets. Soon, these ice crystals become heavy enough to fall. Their final form depends on the temperature of the air they fall through. If the atmosphere beneath the cloud remains below freezing all the way to the ground, they will arrive as delicate and unique snowflakes. If they fall through a layer of warmer air, they will melt on their journey down, arriving at the surface as a cool raindrop. And sometimes, we can see the falling streaks of precipitation hanging from a cloud's base, but evaporating in the dry air before they ever reach the ground. A phenomenon known as virga. And so, the cloud completes its purpose, giving back the water it has carried on its long journey. It is an act of gentle sacrifice, dissolving itself to replenish the oceans, the rivers, the soil, and every living thing, finally closing the great, silent, and ever-turning circle of the water cycle. The great circle is now complete. The water has returned to the earth, and the physical story of the cloud, from its birth to its dissolution, has been told. But there is another story, another life that the clouds possess, one that unfolds not in the high and lonely corridors of the atmosphere, but in the quiet, inner landscape of the human mind. This is the story of what we see when we lay on our backs on a summer's day and allow our gaze to soften. The story of the silent, collaborative art that is created between the sky and our own imagination. It is a universal human experience to look up at the random, shifting forms of the clouds and to see in them the familiar shapes of our world. A dragon, a ship sailing on a blue ocean, the profile of a face, or a running animal. This tendency to find meaningful images in ambiguous patterns has a name. It is called pareidolia, and it is not a flaw in our perception or a sign of a wandering imagination, but rather a beautiful and fundamental feature of how our brains are designed to work. Our minds are extraordinary pattern-seeking machines. For our distant ancestors, the ability to quickly recognize a pattern was a critical tool for survival. It allowed them to spot the shape of a predator hidden in the dappled light of a forest, or to recognize the face of a friend from a great distance. This innate drive to find order and meaning is so deeply ingrained in our neural wiring, so automatic, that our brain sometimes applies it to patterns that are truly random, like the water droplets in a cloud or the grains on a piece of wood. The part of our brain responsible for facial recognition, for example, is so active and so eager to find a face that it will often construct one from the slightest suggestion of two dots and a line. And so, when we look at a cloud, we are not seeing with our eyes alone. We are seeing with the full, rich, associative power of our minds. The cloud acts as a perfect, neutral screen, an ambiguous and ever-changing ink blot upon which we project our own inner world. The process is much like the famous Rorschach test used in psychology, where an abstract shape is presented, and the observer's interpretation is thought to reveal something of their own subconscious thoughts and feelings. The ship that you see sailing in the clouds is not truly there. It has sailed out from the harbour of your own memory. The face you see looking down is a portrait painted by your own emotions on that particular day. The sky becomes a vast and gentle mirror, reflecting back the contents of our own minds. In this quiet and beautiful interaction, the vast, impersonal, and distant sky becomes a deeply personal and intimate space. We are not just passive observers of the clouds. We are active participants in the creation of their meaning. Lying and watching them drift is a deeply meditative act, a form of quiet and wordless dialogue with ourselves. It is one of the very first ways we learn, as children, to exercise the muscle of our imagination, to let our minds wander freely and creatively. It connects us to a timeless, shared human experience, a simple and profound pleasure that has been available to every person who has ever looked up. And so the clouds drift and change, and as they do, our thoughts and daydreams drift and change with them. A silent, collaborative story written by the gentle physics of the atmosphere and the boundless, beautiful creativity of the human mind. The sky, as we have seen, becomes a deeply personal canvas, a mirror for the quiet, drifting shapes of our own inner world. But this connection between the human mind and the clouds is not only a private, individual experience, it is also a great, collective one. For as long as we have been human, We have looked to the sky not just for signs of the weather, but for inspiration, for meaning, and for beauty. The clouds have been a timeless and universal muse, a shared canvas upon which we have painted our grandest artistic, poetic, and mythological stories. In the early 19th century, at the same time that Luke Howard was giving the clouds their scientific names, the great English Romantic painter, John Constable, was capturing their very soul on canvas. He was obsessed with the sky, which he called the chief organ of sentiment in a landscape painting. For 2 years, he produced a series of breathtakingly beautiful and scientifically astute oil sketches, his famous cloud studies. He was not just painting generic, imaginary puffs of white. He was a meticulous observer, a scientist with a paintbrush who would lie on his back for hours, studying the anatomy of the sky. He painted with meteorological precision, capturing the specific forms of cumulus clouds building in the heat of the afternoon, the delicate, feathery wisps of cirrus, and the heavy, grey weight of an approaching storm. On the back of these sketches, he would often make careful notes: the time of day, the direction of the wind, the temperature. His work was a perfect and beautiful marriage of the new science of meteorology and the timeless pursuit of art, a testament to the idea that a deeper understanding of nature only enhances our appreciation of its beauty. At the same time, the poets of the Romantic era were finding in the clouds a powerful symbol for their deepest feelings about nature and the human spirit. In his magnificent poem, The Cloud, Percy Bysshe Shelley gives the cloud a voice, allowing it to tell its own story of eternal transformation. The cloud speaks of its birth from the dew of the earth, its journey with the wind, its power in the lightning and the storm, and its gentle dissolution as life-giving rain. Shelley's cloud is a symbol of nature's creative and destructive power, of a sublime freedom and a beautiful, ceaseless cycle of change. For the Romantic poets, clouds were the perfect metaphor for the imagination itself, free, boundless, and forever creating new forms from the vapor of thought. And this deep, symbolic connection stretches back into our most ancient stories. In mythologies all around the world, clouds are the veil between the mortal and the divine. They are the misty home of the gods on Mount Olympus, the celestial chariots ridden by deities in Hindu scripture, and the form that supernatural beings take in Chinese folklore. They can be a sign of a god's displeasure in the form of a dark and angry storm, or a symbol of divine blessing as they deliver the nourishing rain. For millennia, we have projected our most profound hopes, fears, and beliefs onto this ever-changing celestial canvas. And so, the clouds have served as this constant, silent muse for our collective human spirit. They inspire us because they embody a perfect paradox. They are ever present in our lives, yet they are the very definition of impermanence. They are as vast and powerful as a great storm, and yet as delicate and gentle as a single wisp of cirrus. They remind us of a world beyond our own, a realm of dreams, of spirit, and of constant, beautiful, and inevitable change, a timeless inspiration for the part of us that seeks to find poetry in the world around us. The painter's brush and the poet's pen have long sought to capture the distant beauty and the symbolic power of the clouds, viewing them from afar as magnificent objects in the great theatre of the sky. But what would it feel like to close that distance, to step off the solid ground and walk directly into the soft, white heart of one of these celestial forms? This is an experience that is available to all of us, for on some days, the clouds decide to leave the sky and come down to meet us. When this happens, we call it fog. In the simplest of terms, fog is nothing more than a stratus cloud whose base has formed at or very near the surface of the ground. The substance of the densest fog is chemically and physically identical to that of a cloud floating thousands of feet above our heads. A cool, visible suspension of billions upon billions of microscopic liquid water droplets. Its arrival transforms the world, inviting us to experience what it is like to be truly inside a cloud. One of the most common ways this happens is through a process known as radiation fog. Imagine a clear and windless night after a sunny day. The Earth's surface, which has been warmed by the sun, now begins to radiate its heat back out towards space, and the ground begins to cool down. This, in turn, chills the shallow layer of moist air that is in direct contact with it. As the night progresses, this layer of air may cool all the way to its dew point, at which moment its invisible water vapor will begin to condense into a shallow, pooling layer of fog. This is the quiet, beautiful mist that we often find settled in valleys and low-lying fields in the calm, early hours of the morning, born from the simple, radiative breathing of the cooling earth. Another form, especially common along coastlines, is advection fog. This occurs not from the air cooling in place, but from the air moving. It forms when a mass of warm, humid air from over the sea drifts, or advex horizontally over a much cooler surface, such as a cold ocean current or a snow-covered landmass. The warm air is chilled from below, its temperature dropping to the dew point, and its moisture condenses into a thick, often vast and rolling bank of fog. This is the famous fog of San Francisco, pouring through the Golden Gate, or the thick sea frets that can suddenly envelop the coasts of Great Britain. To be enveloped by fog is to experience a profound shift in sensory perception. The visual world shrinks and softens. Hard edges dissolve, and distant horizons disappear entirely. The world is reduced to an intimate, personal space, a small circle of clarity in a universe of soft, grey diffusion. Sounds, too, are transformed. The tiny water droplets in the air absorb and dampen sound waves, muffling distant noises and removing echoes. The world grows wonderfully quiet. The sounds that do remain, like the call of a bird or the rustle of your own footsteps, become startlingly clear and close. There is the gentle, cool dampness on your skin and in the air you breathe, and the clean, earthy smell of wet soil and plants. And in this quiet, simplified world, our state of mind often shifts as well. The fog removes the distractions of the wider world, gently forcing our attention onto what is immediate and near. It can be a powerful metaphor for a state of uncertainty, but it can also be one of profound peace and introspection. In the gentle, grey solitude of the fog, the clamour of the outside world fades away, and our focus naturally turns inward. To walk within a cloud is to be held in a quiet, meditative embrace, a calm and gentle space perfectly suited for rest, for contemplation, and for listening to the soft, quiet rhythm of our own thoughts. To be held in the soft, quiet embrace of the fog is to experience the world dissolving into a gentle, formless state. This beautiful and introspective experience of being inside a cloud points us toward the deepest and most profound philosophical lesson that the silent travellers have to offer. It is a lesson about the very nature of their existence, and by reflection, of our own. It is the great and peaceful truth of impermanence. We see a cloud as a thing, an object with a name and a shape, a white island floating in an ocean of blue. But in reality, a cloud is not a static object at all. It is a dynamic and continuous process. A cloud is a visible event, a location in the atmosphere where, for a time, the process of condensation is happening slightly faster than the process of evaporation. Water vapor is constantly flowing into the cloud, condensing into visible droplets. At the very same time, at the soft, indistinct edges of the cloud, droplets are constantly evaporating back into invisible vapor. The shape that we see, the beautiful form that we give a name to, is simply a temporary manifestation of this delicate and ever-shifting balance. It is much like the beautiful, sculpted shape of a fountain spray. The shape itself appears to be a constant, stable thing, yet it is made of an entirely new collection of water droplets in every passing second. The form persists for a time, but its substance is in a state of constant, ceaseless flow. Scientists call this a state of dynamic equilibrium, a stable appearance that hides a reality of profound and continuous change. The cloud is never the same from one moment to the next. It is always, and at every moment, in a state of becoming and dissolving. In this scientific truth, we find a perfect reflection of a deep philosophical wisdom, a concept that sits at the heart of many contemplative traditions. In Buddhist philosophy, this is known as anicca, the doctrine of impermanence. It is the understanding that all things, without exception, are in a constant state of flux. Nothing is permanent. There are no fixed, solid, and unchanging things in the universe, only ever-shifting processes and relationships. The The cloud is perhaps the most perfect and gentle teacher of this fundamental truth. To lie on the grass and watch a cloud is to witness a quiet and beautiful sermon on the nature of existence. We see it emerge, seemingly from nothing. We watch it take on a beautiful and unique form. We see it drift and change and morph, merging with other clouds, or stretching and thinning into nothingness. And in this observation, there is a powerful lesson in acceptance and in letting go. The clouds teach us that change is not a disruption to the natural order, but that change is the natural order. Our own lives, our thoughts, our feelings, our very bodies are much like the clouds. They arise, they take on a form for a time, and then they dissolve back into the great, mysterious expanse from which they came. There is no need to cling to any particular shape, to any particular moment, because the nature of all things is to flow. And in this understanding, a deep and profound peace can be found. The clouds show us that beauty is not in permanence, but in the graceful, fleeting, and unrepeatable dance of the present moment. And so, we can learn to accept the gentle, constant flow of our own lives with the same grace and peace as the sky accepts the constant, silent coming and going of its beautiful, transient children. With this quiet sense of peace, with this gentle acceptance of the world's constant, beautiful flow, we take one final look up at the sky and retrace the epic journey we have shared with our silent travelers. Our story began with a single, invisible molecule of water, stirred by the sun's warmth, rising like a ghost from the surface of the vast dark ocean. We followed its ascent on the silent, invisible elevators of the air, the rising thermals that carried it high into the cool expanse of the atmosphere. We witnessed its miraculous birth into visibility as it found a single, humble speck of terrestrial dust to cling to, joining a commonwealth of billions of other droplets to form a new and visible entity, a cloud with a character and a name. We learned to read its form, to recognize the heaped shoulders of the cumulus, the quiet grey blanket of the stratus, and the high, icy brushstrokes of the cirrus. We felt the awe of its transformation into a great cumulonimbus, a cathedral in the sky with a powerful, electric heartbeat of lightning and a deep, resonant voice of thunder. We saw this great cloud become a canvas for the sun's light, its brilliant white scattering the noonday sun, and its soft belly painted with the fiery hues of the sunset. We zoomed out to see it as a passenger on the great, invisible rivers of the sky, a crucial part of the planet's circulatory system. We saw it as both a cooling shield and a warming blanket, a key to the delicate climatic balance of our world. We discovered the secret, teeming life it holds within, a high-altitude ecosystem of the smallest living things, and we journeyed with our imagination to the skies of other worlds, to the acid clouds of Venus and the methane clouds of Titan, a journey which brought us home with a profound appreciation for the gentle, life-giving water, clouds of our own precious Earth. And finally, we watched its gentle return, its graceful act of self-dissolution, as it gave its water back to the world in the form of rain and snow, completing the ancient, life-sustaining cycle, a cycle that is reflected not only in the world around us, but in the art, the poetry, and the deepest philosophies of our own minds. The story of a cloud is the story of the profound and beautiful interconnectedness of all things. It is a story where the fire of the distant sun is woven together with the water of the deepest ocean, where the dust of the earth gives birth to the rain from the sky, and where the vast, silent physics of the atmosphere becomes a mirror for the intimate, creative workings of our own consciousness. The clouds are a constant and gentle reminder that wonder is never far away. It is always there, waiting for us, in the most familiar of sights, if we only give ourselves a moment to pause, to breathe, and to look up. Thank you for joining me on this journey into the story of the clouds. I hope it has brought you a measure of peace and wonder. If you feel moved to, please share a thought in the comments below, and consider liking this video and subscribing for more gentle stories to help you sleep. For now, may your mind be as calm and as peaceful as a clear, high sky. May your rest be deep and restorative. Good night.